Hello, friends. Good morning to all. Today we are going to say about the class 4. It's a set from the Discrete Mathematics. So set also we will get some of the questions. So we'll see with the PYQ questions today. So a set is a well-defined collection of disjoint objects called elements or members. So the objects a set may be numbers, maybe letters, symbols, peoples, and any other well-defined items it can take. So some examples of set we can take the set of all positive integers, a set of planet in the solar systems, a set of all the states in India, and lowercase letters and alphabet. So particularly some examples we can say. Example for a equal to 1, 2, 3, 4, 5. Here elements 1, 2, 3, 4, 5 in the set in the A. So here B is equal to A, E, I, O, U. This is what acts as set of vowels in English alphabet. Okay, so like this we can give. And sets can be represented in three ways: statement form and roster and tabular form and set builder form. Suppose we can say take statement form. Statement forms actually it's a set of all even numbers less than 10, or for example set of all odd numbers or prime numbers, or we can take it's any number, anything. So it will take any set statements they can give in this form. And roster or tabular form means the elements are listed inside the curly braces. For example, A equal to some numbers they are giving 4, 2, 4, 6, 8, 10. This is called the even number. So like this curly braces, we can give number of limited numbers, finite numbers. Finite means it's a limited. Set builder notation. So the elements are described using a property. For example, A equal to X bar. Say X is what? X is a what? X is even natural numbers less than 12. So then it is 12, 2, 4, 6, 8, 10. For example, X is even number less than 100 means what it will take? 2 to 98. So like this, it will take, it's a set builder notations that will give which one. Would say X means what they will give. So depends on that, it has to represent this one in the set actually. Okay, so types of sets. What are the types of sets? This is a very simple only actually. So first one, empty null set. A set containing no elements. For example, empty sets. So this one x less than 0. So this is called, is it first one empty set. Next one, singleton set. Singleton means, for example, only one element. A set containing exactly one element. So A equal to 5. Finite set means, for example, this is a limited number of number of elements. For example, you can take even numbers less than 10. Even numbers, for example, 100, less than 100. Or prime numbers less than 25. Or some whatever. So it's a particular number. It's a not infinite numbers, it's a finite numbers. Just a set of numbers they have given with a limited one. And infinite sets. A set contains infinitely many elements. We can't say n is natural numbers means 1, 2, 3 like this. It's a infinite numbers. Okay. And equal set means A and B, that's a equal set. For example, here A 1, 2, 3 given, B 3, 2, 1 given. So A equal to B. This is equal set. So both are exactly the same elements. This is very simple terms only. That's why I'm going fast. If you not understand, just you can tell me. Okay. Equivalent sets means the same thing. Equal. This is equivalent sets number actually. This one A 1, 2, 3 means three numbers. Just we are finding the numbers. You can see here. This operator is called number of elements. Okay. And subset. Subset means A subset of B means A is a subset of B if every element A belongs to B. For example, A equal to 1, 2 means B equal to 1, 2, 3, 4. What happened here? A is belongs to B. A is belongs to B. For example, I will write A equal to 1, 2, 3, 4, 5, 4, 5. So B equal to 2 and 4. So here what is happening? B belongs to A. That is the meaning. Okay. Now proper subset. A proper subset is a subset that is not equal to the original set. Okay. This original set symbol A, this one, this symbol. Okay. Universal set. The set containing all elements under consideration, so usually denoted by U. So U is equal to this one. For example, universal, the all over this one set. And power set, it's very important. Power set only, very often they will ask you the set of all subset of is given set. And for example, this is two element A comma B. So this subset power set how we'll write? First one we have to write empty set. Next one first single element A, and next is single B. Next join together we have to write A comma B. So this is called power set. For example, 2 means 2 power how many thing? Two values. So sorry, 2 power 2 values. So 2 power 2 is equal to 4 we will get. For example, I am writing A equal to A comma B comma C. So what is the answer? Normally we will get actually total element. This is 3. So 2 power 3 is equal to I have to get 8 elements. Yes. So now we can see here. So here what will happen? This is a blank empty element A, B, just I'm writing fast, C, but we have to write braces. So then A comma B and B comma C and C comma A, then A comma B comma C. So this everything curly braces we need to write. So 1, 2, 3, 4, 5, 6, 7, 8. Totally 8 elements. For example, I'll write, I'm not going to write full and full, just I'm telling you A comma B comma C comma D means what will happen? This one 4 elements. So 2 power 4 equal to I have to get totally 16 elements. Okay. So empty element A, B, C, D and A comma B, B comma C like this we have to get totally to 16 elements. So first single empty element empty and then a single element double and triple and 4 elements. Okay, this is the way we have to calculate power set. Next, the cardinality of a set. Cardinality nothing but as a number of elements they are calculating. For example, A equal to we can take the even numbers of less than 25. So how many elements? 2, 4, 6, 8, 10, 12, 14, and 16, 18, 20, 22, 24. That's all. 24. That's all. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my total number of cardinality of the set is 12. For example, I said actually, okay. The number of subset means what is the number of subsets we have to calculate? Already I told you power set 2 power n. This is separate, this is separate. Same page I have given, this is separate, this is separate. Okay, common number of sets, just for example, maybe they can give infinite, so this one, n means natural numbers 1, 2, 3 like this, w means whole number 0, 1, 2, 3 like this, z means the integers or even negative and positive numbers, this is called this one, and q means rational numbers, are real numbers and complex numbers. So like this also they will give, we have to calculate sometimes. Okay. So next one is the types of sets we have seen. So next a Venn diagram. Maybe through Venn diagram also they can ask questions. That also we are going to see next class actually. So Venn diagram invented by 1880 by John Venn, and just this is it's a Venn diagram we can do like this. So everyone we know Venn diagram. For example, set operation we have set union, set interaction, set difference, complementary offset, Cartesian product like this. What is a set union actually? For example, A equal to this one, numbers they have given set, B equal to this set they have given. A union B means what will happen. So join together we have to write everything but repetition numbers no not allowed. So what happened 10, 11, 12, 13, 10, 11, 12, 13. This 13 no need to write because already is there. So directly 14 and 15. So only once it will write, that's all. This is a union B. Next one, set intersection. So the intersection of sets A and B denoted by this A and B is set of elements which are both the A and B. So for example, both values is there in the present in the A and B, both sets are. Here A you can see 11, 12, 13. B 13, 14, 15. Which one is the common element? So 13 is the common element, the both the sets are. So this is called 13. This is the intersecting of A and B. Next set difference are relative complement. So here we are going to minus A minus B are like this. So set difference of sets A and B denoted by A minus B. For example, here what A value 10, comma 11, comma 12, comma 13. So what is the B value? 13, comma 14, comma 15. So I'm going to minus this value and this value. Yes. So 13 will get this one deleted. So what is the remaining value? 10, 11, 12. So that is called A value, remaining value we will get. This is the procedure. Okay. Suppose B minus A means also we need to write depends on the number they are giving in the set. Complement of set means the complement of set is denoted by A dash. Just A dash. It has to write only dash. This is a set of elements which are not in the set A. For example, U minus A. For example, I am writing U is equal to minus 1, 2, 3, 4 up to 10 I have given in the U. For example, A I have given this is called 3, 5 and 9 only is there in the A. So what is A minus? So U minus A we have to calculate is. So what is the value we will get? So here 1, just you can get minus this and this. So 1, 2, 3 won't come. 3 won't come. 4, 5 it won't come. 6, 7, 8, 9 it won't come and 10. So this is the minus A complement of A value. Cartesian product or cross product. That one we saw in the last class itself. Just we are going to multiply. For example, A comma A1, A and 1 2 means A comma 1 and A comma 2 and B comma 1 and B comma 2. This is just a product of this one sets. Next one, function. So functions also sometimes we will get question. This is all those are basic questions. But we have to know, we have in the syllabus actually in the discrete mathematics. Okay, so function is a mapping which element a set A is uniquely associated with the element of set B. So the set of A is called domain of a function and set B is called codomain. This is domain, this is codomain. So depends on the function they have given, it has to match actually. We are going to see that sum actually. For example, this f of x equal to I'll calculate x squared means just I'm going to calculate x squared depends on the numbers which they have given input. Okay, now we will see that sum. So before that we have what is domain, what is codomain, what is the range of function. So domain, what I said, this is actually domain, this is codomain. How we are going to connect this one depends on the function, range of function which we are going to connect. The range of function is a set of picture of its domain. Okay. Now example you can see. So find the, I am going to calculate here domain, codomain and range of functions. So first what they have given, A equal to 1, 2, 3, 4 they have given. B is equal to what they have given? 1, sorry, from here also 1, 2 to 18, up to 18 they have given. So I have written a domain here. I have drawn so codomain here up to 18 I have to draw. Sorry, okay. Now, what is the function f of x equal to x squared? So, 1 squared is equal to 1, 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16. So, I am going to connect 1 with 1, okay, 2 with the 4, and 3 with the 9, and 4 with 16. So, this is the way to we have to calculate this function. So, domain, codomain, and range we have to do. Okay. Next one, let a equal to this one, b is equal to this one they have given. So another example, f of x equal to 2x we have given. So what is equal to, this is 1 into 2 is equal to 2 it will come, and 2x means 2 means 2 into 2 4 it will come, 3 into 2 6 it will come, 4 into 2 8 it will come, 5 into 2 10 it will be there. Okay, it will become. So I didn't write it. Suppose for example if you want to draw the diagram, so in this domain, we have to write 1, 2, 3, 4, 5 we have to write. In codomain, what will happen? So here we have to write 1, 2 to 14 I can write. So 2, 4, just in middle I am writing here 5, 6, 8 like this 14. So 1 we have to connect with the 2, 2 we have to connect with 4, 3 we have to connect with 6, 4 we have to connect with 8, 5 it has to connect with 10 actually. So like this is so domain is this one, codomain this one, and range will be this one. Actually here the codomain what they have given like this. For example, even numbers only means even numbers only we can write. Sorry, types of functions. So here we have three types of functions. Injective means one to one function. So an injective here, what is the types of function? Three types: injective, surjective, and bijective. Injective means one to one, surjective means onto function, and bijective means next we are going to see. So one to one onto. Actually, simply we have to know what is injective, what is one to one onto. They will ask you in the match the following questions. Till now, we got in the match the following questions. But this is theoretically we need actually. Okay. So the injective one to one function is a function which differ elements of the domain have different images on the codomain. No two destinate inputs map the same input. Okay, subject to onto function. Again, I'll tell you this naming itself we need. It's very important. The name, it's a very important keyword actually. So theory papers you can take even paper 1 and paper 2. For example, the teaching aptitude, research aptitude, and the ICT and like this theory papers. Where even paper 2 theory also we need to take a keywords. Okay. The subjective onto function is a function which every element of the codomain has at least one corresponding element in the domain. So no element codomain of it's, left unmapped. For example, here you can see this one A, this one they were given, B they have given. How we are mapping you can see. So three same element we are mapping 3 to C and 4 to C. So it's a surjective function as every element of B is image of this some A. And bijective one-to-one onto function. So the bijective one-to-one onto function is a function in which every element of the domain has a unique image of the codomain. And every element of the codomain in this the image of exactly one element of the domain. So this is called X like this, the same diagram which we have given. Okay, so some just some questions. A set containing no elements is called empty set. So like this will be there, no element, R1 by symbol will be there. Okay, if A equal to 1, 2, 3 and number of subsets, A is actually number of subsets. What is the formula? 2 power n. So how many numbers are there? 3 numbers are there. So 2 power 3. So what is the value? 8 value will be the answer. So number of subset formula we need to know. So again, I'll tell you in WhatsApp group, I told you in the channel itself, we have WhatsApp group, just you can join those who are interested. There, every formulas and questions, definitions, we will post very often. Okay, the cardinality of A is, cardinality means what actually? It's a counting, number of elements in the set actually. So number of sets, element actually 5 element, that's a set. This is the cardinality of this set. Okay, so till now sets is the over. So next probability we are going to see the next class is very interesting probability and graph theory, group theory, and hereafter we are going to see it's a very different questions also will cover actually. It's very important. We are going to see graph theory. It's really will get three questions, minimum three questions. Prim's algorithm, Kruskal algorithms, and like this. So and Euler theorem and Hamiltonian circuit, planar, non-planar, like this. Many questions what they are asking regularly. So we are going to see in the upcoming videos. Kindly subscribe and just you can watch every videos. And if you have any doubts regarding that, you can ask me in the comment section or even WhatsApp group also. Thank you all of you. Thank you once again.